Hi everyone, my name is Varun. I studied operations and supply chain from Queensland Polytechnic University, British Columbia. So I hope everybody is doing well and great and enjoying the weather outside, right? So I started I just completed my studies at Queensland Polytechnic Universities and started making YouTube videos and sharing my concepts that I learned during my studies because I spent a lot, right? $40,000. So I thought of like transferring my concepts to you, to everyone, so that everyone can learn who is studying operations and supply chain, which is core of any of the businesses around the world. So today, like we are going to solve the transportation issues in supply chain with the help of the Excel solver model. So thanks for coming on this YouTube video and just watch it and just learn just apply the concepts on Excel and you can use further in your any of the operations issues in transportation. Thank you. Learning supply chain. So today I would be talking about the transportation transshipment problems that we face in meeting supply and demand and managing our capacity. So today I have an example I want to use and explain the MS Excel solver model, and you would be able to figure out how we are able to cater this transportation issue. So this is Guinness Biscuit, and which is located in Mount Crawford, Virginia, US, and they have three bakeries at three locations. So these are the three locations which is mentioned, and these are the capacity they have. So I will just highlight this capacity and what are the customers location that they want to deliver this. So these are the customers location. So I will highlight this as well. So these are the customer locations. And what are the distances between the customer's location and the bakery? So we need to figure out which bakery is more suitable to deliver the order and managing their capacity within. So these are the customer locations and the bakery's distances. So first bakery is Dayton and the first customer location is Bridgewater. So the distance is 3 miles. So we will figure out how we can figure out how we can examine which bakery is more suitable and maintaining the minimum viable cost. So we will calculate the minimum viable cost and we will be able to figure out which bakery is more suitable, and the cost per mile is $0.25. So what I will do is I will just copy this data, which is the distance between the bakeries, three bakeries, and the customer locations. So I will just use Control C and we'll just paste it here. So this is the outbound transport. Outbound transport means from the bakery to the customer's location. So I will just type outbound transport. So this is outbound transport, and I will just what are the number of quantities that we need to deliver. So the quantities we do have, we are taking it as one initially, and we will be able to figure out like how many quantities are matching this uh, matching this example. So I will just use select this. I will just type 1 and control enter. So these are the examples. We have taken the 1 as the initial quantity that we are going to deliver at these locations from these places. So we will be able to get the exact number using the solver model. Now we will calculate the cost. How do we calculate the cost? The distance multiplied by the quantity. So we will use the sum product formula, that is as sum product. So this is the formula, and we will be using the first this one, like what is the distance between each location. So this cell range you are able to see on my screen. I am selected the cell range from C18 to E27. So I selected this range multiplied by the quantity. What is the quantity? The cell range is H18 to J27. So I will just close this, multiplied by the cost per mile. So this is the exactly the total cost. So this is the total cost that we are getting if we deliver one unit from each of the bakery's location to the customer's location. So we are delivering one unit to Bridgewater location from every bakery, Dayton, Harrisonburg, and Mount Rayford. So now we will figure out how to calculate the the quantities from each bakery. So we're gonna use the solver model. To use the solver model, we need to transfer this or transpose this into rows. So I will just select this. I will just copy. I will just paste this. When I paste this, I will get the option I will transpose. So I will just paste this as a transpose. So this is like in the row format. So now we will use the solver model and we will be able to identify like how many quantities we need. So we will go to the data. So on the top bar, you see the data option. Use the data, we go to the solver model, and what is the objective that we want to maintain? We want to minimize the cost, and we need to select the cost. What is the objective? We want to minimize. First is minimize. What do we want to minimize? We want to minimize the cost. So we will just select the cost. Where is our cost? Our cost is this. So we select this. So I selected H30 as my cons. What do you want to change? We want to change the quantities that we want to deliver from each of the bakery. So we will set the quantities. Where are the quantities? The quantities are here. So we will select this cell range. So this will change. What will change? This will change, right? So this will change. So I will just select this. So I selected this. Now, what are the conditions where we do have? The quantities are always in the integers. So we will add the quantities. What are the quantities? What are the constraints? The constraints are the quantities here. So first the quantities. So I will just select this. These are the quantities and I will just mark as integers. These are integers. So integers can be positive and negative. So the next constraint is we select the quantities again. So this is the quantity. We will select this and this should be greater than equal to 0 because these are always positive, more than 0. Either be 0 or like more than 0. So I will just select equal to or greater than 0. Next is like our total quantities. So if you want to like the total quantities here, like how many locations we do have, one second. So what are the total quantities that is delivering from the each bakery to the this location, Bridgewater. So I will just select this and I will type alt equal to. So these are the total quantities that you are getting in this order. And if you go to this one, like what are their capacity? So the total quantities that is delivered by each bakery should not be increasing their capacity. So I will just select this. I will type alt equal. So this will sum all the numbers like the bakery's capacity, which is 10, 10, 10. So which is less than the actual capacity, right? So this is actual capacity as taken is as 1 to solve this. Now we need to add more constraints. So we go again on data, we go again on solver, and we have already added the 2 constraints. Now add the more constraints. So the next constraint is this this cell range, the total capacity should be less than the actual capacity. What do they have? So the actual capacity is this. So this I have added. So this is also the next constraint. Now what is their total demand? What are the numbers that we need to deliver to these locations? So the demand is 5, 12, 7, 10, 15. So this is on the left side. If you say top left side, demand and customers. So demand is this and customers are this. So we need to match this demand. So we'll select this. This is the demand. This should be equal to the total number we are going to deliver. Which one? So this is the total number we are going to deliver. So we will select this now. So this is the total demand. We are delivering to Bridgewater location, one from Dayton, one from Harrisonburg, one from Mount Rayford. So I will just add this and we'll click on cancel. So these are the constraints we have added. Now we have added these constraints. We click on solve. We have used the GP nonlinear. We will use the linear progression. So I will go again on the solver. So this is GRG nonlinear progression. So I will use simplex linear progression. So I will click on simplex linear progression, click on solve and keep solver solution. I will click OK. So you get the exact number that you need. And this quantity, if you see, is matching with this quantity. I'll just paste here so that you can view. So this is matching with this because we have created the solver model and you would be able to solve the problem. So this we are going to deliver 5 units from the Bridgewater location and it's maintaining the minimum cost. What is the minimum cost? We are getting 206.50. So this is the minimum cost that we are getting and we are getting like 5 units from this. So this is the minimum. This is like pen lead is like little tricky, like 2 from 13. We can sort it out. So this is the solution that we have made it out and we are able to deliver the exact unit that we want. Thank you so much guys. Keep watching my videos, keep learning the concepts, how you can solve the transportation issues on supply chain from by using the Microsoft Excel. Thank you. Have a good day.